Hello friends, this is Priyanka. Today we are going to solve a problem on cams and follower. We are going to use the follower of knife edged. Now first I will read what is the given problem. A cam is to give following motion to a knife edged follower. First, outstroke during 60 degree of cam rotation. Second, dwell for next 30 degree of cam rotation. Third, return stroke during next 60 degree of cam rotation. And fourth, dwell for the remaining 210 degree of cam rotation. The stroke of the follower is 40 mm and the minimum radius of cam is 50 mm. The follower moves with uniform velocity during both outstroke and return stroke. Draw the profile of cam when first the axis of follower passes through the axis of camshaft, and second the axis of follower is offset by 20 mm from the axis of camshaft. So this was the given question. Now we will understand some basic concepts regarding this cam and follower. So first, according to this given information, we have to draw one particular graph. So for that we have to take the abscissa, that is x-axis, and ordinate, that is y-axis. So what this abscissa represents? So abscissa, or we can also say the base, represents time for one revolution of cam, or we can say angular displacement. So we know that the cam rotates through 360 degree. So we have to make some equal parts as per the given data for this 360 degree with some suitable scale on the abscissa. Now second, for the ordinate, it represents the displacement or velocity or acceleration of the follower. So from this we come to know that the abscissa represents the time related to cam rotation, and ordinate, that is the y-axis, represents the displacement or velocity or acceleration of the follower. Then what is this dwell period? So in this question dwell period is also mentioned. So follower remains at rest during cam rotation, and that period is known as the dwell period. That means there is no any movement of the follower. So we have to take it as a constant. Now according to this given information, if we observe this cam rotation, we can say that this angular displacement of this cam is given in degrees. So for one complete rotation, cam rotates through 360 degree. So we will take here one particular scale, that is 1 centimeter is equal to 10 degree. That means for 360 degree we have to take here scale, that is 36 centimeter. Now we have to make some equal parts, but in which portion we have to make equal parts? So if we observe the question, here outstroke is given for 60 degree, then dwell is given for 30 degree, and then return stroke is given for 60 degree, and again dwell is given for 210 degree. So during this 60 plus 30 plus 60 plus 210, that means during this 360 degree cam revolves about one complete rotation. Now this outstroke and for return stroke we have to make equal parts of this number of degrees given. So we can take any number of equal parts, maybe 5, 6, 7, 8 or maybe 12. Now how to decide that how many parts that we have to take? Now if we observe here 60 degree and 60 degree it is given. That means we can easily make 6 number of equal parts. That means for 10 degree 1 part. So for this 60 degree, now here scale is 1 centimeter for 10 degree. So we will take first as a 0, then here 1, 2, 3, 4, 5, 6. Now this total 6 centimeter indicates for 60 degree. Then this is, we will say abscissa. So and the abscissa we have to make first here the 6 equal parts, for each part is for 1 centimeter apart. So this 1 centimeter indicates for the 10 degree. So in this way this 60 degree is getting completed for outstroke. Then outstroke, there is the dwell period. So in this period the follower remains at rest. So here there is no any movement of the follower. So for next 30 degree, that means next 3 centimeter, there is no movement of the follower. So no need to make here the parts. Then next is return stroke. So for return stroke again, we have to make 6 number of equal parts. So here I will say starting line will be at 0 dash, then 1 dash, 2 dash, 3 dash, 4 dash, 5 dash and 6 dash. So if we measure 1, 2, 3, 4, 5, 6 number of equal parts. So here is the 60 degree. And the remaining part is 210 degree. So instead of showing all this part, we can show here as a short part because this is the dwell period. So no any number of equal parts should be made. Now this is about the abscissa. So here we have to give the letters at the start and end point of the outstroke as well as return stroke. So I have given here A to S and here T to P. Then we will move for the ordinate. So for the ordinate here stroke is given. So stroke, that means we will say displacement. So we know that the ordinate represents displacement or velocity or acceleration of the follower. So here stroke of the follower is given and that is equal to 40 centimeter. So according to scale we can use here 4 centimeter or we can use here scale 1:2 or 1:3. That means we can take this ordinate at the 8 centimeter or here 12 centimeter. So this is the vertical line that we have to take and we have to draw this graph. So in this way we have to also note here outstroke, dwell period, return stroke and dwell period. So in this way this graph is getting completed. Now we have to show the displacement according to this number of degrees. So here for during outstroke and return stroke only we have to show the displacement. Why? Because during dwell period follower remains at rest. So now here what is the condition is given. So if we observe the question carefully, here the condition is given follower moves with uniform velocity during outstroke and return stroke. So this is the outstroke and this is the return stroke. So here the velocity of the follower is uniform. So we can say that the displacement we have to show or displacement diagram consists of straight line. So I have to show this one straight line joining the end points during outstroke and in the same way for the return stroke. So how to show that straight line? Now if I observe here, this is the point A and this is the another corner. So outstroke, here the displacement should be straight line in this way. So I will join. Now when the follower is at this stage, that is the stroke of 40 millimeter, so sorry here 40 millimeter is there. So when the stroke of 40 millimeter is getting completed, then suddenly there is the dwell period. So in dwell period no any movement of the follower. So it remains constant. So I have to extend this point up to this starting point of the return stroke because in the dwell period there is no any movement. Then what is happening in return stroke? So follower again coming back to its original state. But how? With uniform velocity. So how we can show the uniform velocity? With straight line. So I have to show the uniform velocity, that is in return stroke followers coming to its original state but with the straight line displacement. So I will show here the straight line. And again for the dwell period it remains constant. So in this way this is the graph getting completed. So now I have to give some letters. So I will give here the letter, that is this straight line intersects this first gap, or we can say first part at this line 1. So I will say this will be B, then C, D, E, F, then here will be G, then here will be H, I, J, K, then here will be L, M, So these are the letters that we have to use later. So in this way this graph is getting completed. Now we will move for the first case. That is, we have to draw the profile of cam when the axis of follower passes through the axis of camshaft. So for that, first we have to draw one base circle with 50 mm radius, because the minimum radius is mentioned in the question. So take O as a center and draw here one circle with 50 mm radius. And then the condition is given that the axis of follower. So here is the knife edge I have shown, and its axis is passing through the axis of camshaft. So here is the center O, and from that center this axis is passing. So this is the first condition. So from this center O we have to draw one vertical line, and here this vertical line is having the same axis for this knife edge follower. Now for this condition we have to draw the profile of cam. Now this circle indicates the angular displacement. So what is the total displacement of cam for one revolution? So total displacement is 360 degree. And here also for one rotation of cam the total degrees, that is 360 degree. Now if we observe here the outstroke is for 60 degree, then there is dwell for 30 degree, and return stroke is for 60 degree. Now our knife edge is at this point A. So if we observe, this is the center O, and initially the knife edge is at point A. So we have to transfer here this point A. Then we have to take 60 degree angle, that is AOS, because here this total 60 degree angle is getting completed in this displacement diagram with A to S. So here this is linear displacement diagram, and this is the angular displacement. So here also we have to take the angle AOS, which is equal to 60 degree. Now make equal number of parts that we have made in the displacement diagram. So here there are total 6 number of parts made. So here also we have to make 6 number of parts, that is 10 degree for one part. So here is 1, 2, 3, 4, 5, 6. So these 6 parts are getting completed. Now after that we have to take 30 degree angle, that is SOT, because during this displacement S to T there is 30 degree angle. So we have to take SOT, that is equal to 30 degree. And then this is the dwell period, so no need to make the parts. And then T to P is again 60 degree. So again we have to take here TOP is equal to 60 degree, and we have to make these 6 number of parts, that is for 10 degree one part. So mark here the points at 10 degree apart and draw the lines passing through that. So in this way here the number of parts are made. Now we will give here the notations. So from this point A, here the for first part, that is for the initial line, there is number 0, then 1, 2, 3, 4, 5, 6. So as here mentioned. Then for S to T there is no any parts, but at the initial line of T there is 0 dash. And then after 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, 6 dash. And at 6 dash there is the point P. So we have to make the equal parts in the same sequence as in the displacement diagram. So this we have to cross check. Now we have to transfer this stroke for the follower. So here at point A it is 0, that is knife edge is here. But what is happening when it is passing through the one part? So the knife edge will reach to the point B. So in the displacement diagram we have to transfer the same distance from 1 to B. So with the help of compass we can transfer this distance. So from 1 to B I will mark here one point, and this point will be point B. Then the next is 2 to C. So in the same way we have to transfer here 2 to C. So make here one part, then C. Then 3 to D. So transfer from the compass, that is 3 to D. Then 4 to E. Then 5 to F. So we have to give the same letters. And then 6 to G. Then here 0 dash to H dash. So it is equal to 6 to G. So again we have to use the same distance. So here H. Then we have to take the distance 1 dash to I. Then 2 dash to Z. And so on. So here we have to join the selected points. So in the same sequence we have to join, that is A, B, C, D. So here A, B, C, D, E, F, G and then H. So in the same sequence if we join, then this is the cam profile and that is getting completed. Now we will move for the second case. Here we have to draw profile of cam when the axis of follower is offset by 20 mm from the axis of camshaft. So where is the axis of follower? That is 20 mm offset by axis of camshaft. So the axis of camshaft is passing through the center O. So first we have to draw one circle with 50 mm radius and O is the center. So here is the axis of the camshaft. So from this axis of camshaft we have to draw one distance that is at 20 mm apart. We will draw here one vertical line. And this vertical line is in the form of the dash is the center of the follower. So our follower is the knife edge follower. So I have shown here with this center, that is the with this point. So initially the knife edge is at point A. So this is the linear displacement diagram and this is the angular displacement diagram. So this linear displacement in terms of outstroke, dwell and return stroke given, we have to convert it into angular stroke, angular displacement. So here first outstroke is at 60 degree. Initial position of the knife edge follower is at this point A. So we have to join this point A with this center. And now with the help of protractor we will make here the angle of 60 degree. So take here OA line as a base and mark here one point at 60 degree angle. And then there is the dwell period for 30 degree. So again for next 30 degree mark here one point. And then again there is the return stroke for 60 degree. So mark here one point at a 60 degree. Now we have to make the line. So initial position of knife edge is at point A. Then when it completes outstroke, what is the position? That is at point A. So if I draw one line passing through the 60 degree line, then here will be point S. Then when it completes its dwell period, then again there is the point T. So I have shown here. So here is the point T. And then when it completes its return stroke, so here return stroke we have to make angle, that is again we have to take 60 degree. Here is the point. So again we have to draw one line passing through this point. So I will give here the 60 degree, then here is 30 degree and again there is 60 degree and the remaining is 210 degree. So this is the remaining angle. Now we have to make its equal parts as made in the displacement diagram. So here for 60 degree we have made 6 equal parts. So again for return stroke for 60 degree we have made 6 equal parts. So in this angular displacement diagram we have to take each angle by 10 degree because 60 divided by 6, that is equal to 10. So again I will mark here the points at 10 degree apart. So 1, 2, 3, 4, 5, 6. Then here 1, 2, 3. Then no need to make partition for the dwell period. So again for return stroke we have to make here the 6 equal parts. We have to give the numbers on the base circle for this equal number of parts. That is, first initial position of A is at 0 line. So at this point A we have to give the number 0. Then again for 10 degree apart, here this point is getting selected, that is 1, 2, 3, 4, 5, 6 and so on. So here is also, then again after 30 degree dwell period, again we have to give here 0 dash, 1 dash, 2 dash. So we have to follow the same sequence as in the displacement diagram. So here this circle is offset. So this is the offset circle for 20 millimeter radius. Now how to draw here the profile? So for that we have to draw the tangent line passing through this point 1, 2, 3 and so on. So first I will draw one tangent line passing through this point 1. Then again point 2. Then point 3. So these are the tangent lines to this offset circle. Then in the same way, now for dwell period no need to draw the tangent line. So for this again for the return stroke we have to draw the tangent lines to the offset circle. So this is the line passing through 1 dash. Then the next is the line passing through 2 dash. Then again the next line is passing through 3 dash, 4 dash, 5 dash and 6 dash. So these are the all are the tangent lines. Now it is easy for us to transfer the distance. So initial position of the knife edge is at point A. Now what is the next position is at point B. From this point 1 to B. So we have to take this distance and we have to transfer the same distance. So I will use here the black marker. So 1 to B. So transfer here the distance, that is here is the point B. Then 2 to C. So here we have to transfer here the distance 2 to C. Then 3 to D. Then 4 to E. 5 to F, and 6 to G. Now the same distance is from 0 dash to H. So here is the line, that is 0 dash to H. So I have to extend this line. That is, I have to draw one line passing tangent line passing from 0 dash. So here is the, at this point T there is the 0 dash point, because here we have to observe at this T point there is the 0 dash. So I will draw here one tangent line. And now we have to transfer this same distance. So I will use here the again black marker. So here is the point H. Then we have to transfer 1 dash to I. Then 2 dash to J and so on. So here we have to join the points, that is A, B, C, D, E, F, G, H, I, J, K, L, M and P. So this is the cam profile that is getting completed.